Hi everyone, my name is Dawson. I am currently a nursing student at GCU in Phoenix, Arizona. I am in my fourth and final semester of my nursing program, and today I'll be going over some dimensional analysis and med math that you will see during a nursing program, whether you're at GCU or not, because this applies to any nursing program whatsoever. So before I get started, just want to apologize for the setup. I got a stack of solo cups here because I don't have any fancy rig. We are in nursing school after all and poor, so we are figuring this out. But I'm not sure how it is in other nursing programs, but when it comes to med math here at GCU, and I believe this applies to most nursing programs, these exams are pretty much pass-fail. So at our school, you have 10 questions. 10 questions. If you get a 9 out of 10 equals 90%, then you pass. But you get 3 attempts, right, to pass this exam. And just like with what we call PBAs, professional-based assessments, or performance-based assessments, you also get 3 attempts on those. That's a completely different topic, and you can refer to some of my prior videos for information on those. But with these med math exams, you have 3 attempts. With the first attempt, if you pass, you're good, right? But if you don't pass, you don't get any credit at all when it comes to your grade, because these points get put into your grade book. It's not a lot, but I mean, if it comes down to the wire, this could actually end up impacting your grade throughout the semester. But then you get a second attempt and third attempt, right? Now my handwriting's pretty awful, so bear with me. If you don't pass that second attempt, you still get 0 points, right? But if you don't pass that third attempt, nothing goes into your grade book, right? But if you don't pass that third attempt, then you don't move on through the program. You actually fail out. This is unfortunate, but just a reality. And so at that point, if you don't pass your third attempt at a med math exam, you don't progress on through that class. And I've only seen this happen once with one person, and it was honestly a fluke. It was just because they were incredibly nervous, and they ended up getting readmitted into our program, and now they're all good. So now that I'm done with prefacing that, why don't we actually get into some med math? So starting out with what you'll see at the start of your first semester, it's going to be very basic. You may be thinking to yourself like, okay, this is way too simple, but calm down now, because it will get more difficult. But now, speaking as someone who's at the end of their nursing program, med math is really not difficult. You just got to pay attention, check your decimal points, your rounding and whatnot, and it's pretty straightforward. And conversions are very important in med math. So very basic stuff. So if we have 3.45, right, and we need to round to the 10th, then we would round to 3.5, right? Simple enough. If we have 5.616 and we need to round to the 100th, right, we're going to round to 5.62. Very basic stuff. And this is on par with what you'll see at the beginning of your program. You'll also see at the beginning of your program conversions. So liters to milliliters, milliliters to teaspoons and tablespoons. I don't know the abbreviation for tablespoon, but that's how I write it. Pounds to kilograms, right? Stuff like that. It's going to be very common for you to see. So why don't we just do this? I'll run through these real quick, and then these are going to be helping us through the rest of the questions, okay? So for each liter, I know that there's 1,000 milliliters per 1 liter, right? For tablespoons, 1 teaspoon, I know just off the top of my head that 5 milliliters are in 1 teaspoon, but in 1 tablespoon, there is 15 milliliters. And then for kilograms to pounds, I actually still mess this up a little bit every once in a while if I'm not thinking straight or got my head screwed on tight. I flip these when I'm not paying attention very well. But I just checked before starting this video, and yeah, let me just verify real quick. Yeah, so there are 2.2 pounds per 1 kilogram. So these are some basic conversions that you're going to need to know as you get into med math. But very typically, they will give you a sheet or some practice questions, which I actually have pulled up here on my computer, but I'm not sharing with you just for the sake of plagiarism, I guess. I just don't want to share something that's posted by my school without their permission, because I don't want to risk getting kicked out for some reason. But I will be conveying it down here on paper in a slightly altered form. So why don't we actually get into some questions real quick, and we'll run through it. So let's talk through this. I have a medication that is ordered for 25 units per kilogram to be given IV, right? The patient weighs 155 pounds. Correct dose equals what, right? Okay, so units is something that I actually didn't show up here. When we talk about unit conversions, this is what you're familiar with, this. But units actually is its own unit. So you'll see this with medications such as heparin, for example. But that's besides the point for the sake of this question. So if we have 25 units, I will write U for the sake of this, per kilogram, 1 kilogram, then I need to end up converting pounds to kilograms, right? So then I would do, let's see how I'm going to work this out. So if I got 1 kilogram up there, 2.2 pounds there, times 155 lbs. So yeah, that would end up giving me, because if I see these units up top and bottom, I can cancel them out. So I can cross out pounds, I can cross out kilograms. That would leave me with specifically just units, which is what I want to get the correct dose. So let me do some calculating right here on my computer, since my phone is recording this. So 155 calculator, 155 divided by 2.2 equals, so this equals 70.45, repeating both of that. That's not important for the sake of this question. But then I multiply that times 25. And that gives us a total, this is going to get very messy, just forewarning you. That gives us a total of 1,761.36, but the 36 is repeating. And then let's see if it tells us what we need to round to. We're going to round to tenths. So this is going to be 1,761.34 units. Let me check my work to see if that is correct, and that is correct. So the answer for this question, I'm actually not showing you the question as it's shown to me, but I'm breaking it down to a very basic format that will benefit you when you're writing this out. So you get the information that you need, right? So we have the medication. This is how it's prescribed, 25 units per kilogram. The patient's weight is 155 pounds. What is the correct dose? That means that we have to identify how many units or whatever this would be. In some cases, this would be milliliters or milligrams. But yeah, so within this, we got the weight out of the way, and we converted pounds to kilograms and then multiplied it by the units to get 1,761.4 units, which is correct. This right here is dimensional analysis. I will admit I did this backwards because sometimes I accidentally do that, but typically you will see it in a grid format like this. So let's actually redo this question real quick and show how it would be done with correct dimensional analysis. I don't use this very much because it doesn't work with the way that I think, but yeah. So let's rewrite this. We have 25 units per kilogram. So let's say 155 pounds. Typically right here, you want to start with something that has nothing that would go under this. And then we're going to find, we have 2.2 pounds. This is our conversion right here to 1 kilogram. And then we have 1 kilogram per 25 units. And whatever answer or whatever unit you want to end up with, here is U for units. This would be milliliters in other cases, or milligrams. You want to have that here in this top section. You see how here it was in the top section? That is how you will end up with the correct answer. And so now that we see we have pounds and kilograms up top and bottom, so we can cross those out. Those units are negated. And then when we ran the math, we end up getting 1761.4. And the only remaining unit is the U right here. So U. And that is how we get our answer. So this is the format that will follow you throughout all of nursing school. So let's move on with something a little bit more difficult and see if that can be done. Okay. So this one is a little more difficult. So we have a medication that is 6,000 units to be given subcutaneously every morning. There's a 5 milliliter vial that contains 5,000 units per ml. How many milliliters do we need to draw up in our syringe? Okay, and then we're going to round that to the tenths. So order is 6,000 units to be given SQ every AM. The vial that we're going to be drawing the med out of is 5 milliliter per 5,000 units. And we need to find milliliters, right? So the answer that we're looking for is milliliters, right? We're given the order and we're given the conversion right here. So let's just run this. So here we have 6,000 units, right? And then we're going to put units down here. And then 5 milliliters up top. Those units cancel, leaving us with milliliters. So when we do this calculation, we're going to get our answer in milliliters. So I can't do that off the top of my head, so I will actually run that real quick. 6,000 times 5 divided by 5,000. And so our answer is 6 milliliters. See? So this is dimensional analysis in a nutshell, and this is another type of question that you'll see. Let's, actually let me verify that that's the correct answer. Wow, that is very not the correct answer. I actually take that back. I read the question wrong. It did not say that it's per 5 milliliters. It said per 1 milliliter. So you see how common it is to simply mess up just because you misread something? So if you look closely here, I had written down that every 5 milliliters is equivalent to 5,000 units. But actually, every milliliter is equivalent to 5,000 units. So if we change this 6 times 1 divided by 5, 6 over 5, because you just do the math. 6,000 times 1 divided by 5. Break that down. That's 6 divided by 5. We're going to scribble that out. 6 divided by 5 is 1.2 milliliters, which is actually the correct answer. So a mistake as simple as misreading the question resulted in us getting a completely different answer. And that does happen. That happens to me every once in a while, and it will happen to you. But I had read it. Well, let me just read this to you. It says the 5 milliliter vial on hand is 5,000 units per ml. So I read 5 milliliter vial, then I see another number, that's 5,000 units. But actually it was, the vial contains 5 milliliters, but within that, the concentration is 1 milliliter per 5,000 units. So little mistake there, but we came to the right answer. So let's move up to another question. So we have azithromycin, AZI, as I like to say it. So the order is 250 milligrams once a day, 1 times a day, for 4 days, okay? The supply is 100 milligrams per 5 ml. So how many milliliters, are we going to be given daily? Right? And then we round to the tenths. Okay. So here we have our information. This is our med. We can completely ignore what the med is, right? This is what's ordered by the doc or the provider. 250 milligrams of this medication to be given once a day for 4 days. Our supply is 100 milligrams per 5 milliliters. So how many milliliters are we going to give per day? So per day, we know that 250 milligrams are going to be given. So now we just need to run this calculation. So if we have 250 milligrams times, this is actually how I do it, 250 milligrams, because I don't do the box thing like up here on a normal basis. I do it like this. So you have 250 milligrams, and then we're going to throw this in here, 100 milligrams down there, so those can cancel, and then we have 5 milliliters. So we just took this, plopped it down there, and then now we get 250 times 5, which I believe is 650. Let me calculate this, 250 times 5, and then that is not 650, that's 1250. So then we divide that by 100, and that gives us with 12.5 milliliters per day, okay? Now, if they had asked us milliliters total instead of just daily, then we have to multiply this times 4, right? And so they can mix it up in an infinite number of ways, and it will catch you out every once in a while. Now let me verify that this one was correct. Correct. Okay, but now it's going to ask us how many teaspoons per dose are we going to be given? Teaspoon per dose. Same question, or same information, same question. Think of it as just part A and part B, right? So now we got to throw this into teaspoons, right? And then if you can't remember right now what teaspoon to milliliters is, then you need to refresh. And it's super simple to pick up on. So we have, let's see, 12.5 milliliters. So then we need to have milliliters down here and teaspoon up here. So those can cancel. And then we have 5 milliliters per 1 teaspoon. So then 12.5 divided by 5 equals 2.5, which is the correct answer, 2.5 teaspoons. Okay, so pretty straightforward. I think you're catching the drift. Let me grab another sheet of paper and we can do a couple more. So this is going to be with pills and tablets. So the order is 250 milligrams of metoprolol 2 times per day, right? We have 100 milligram tabs on hand. So we need to figure out how many tabs are we going to give per dose. Okay. So this means that each tab is 100 milligrams. Okay. So we need to do 250 milligrams there. Multiply that by 100, milligrams. I made a mess right there. Per 1 tab. I can do this pretty simply. 250 divided by 100 equals 2.5 tabs. And then to verify that, that is the correct answer. So 2.5 tabs will be given per dose. Now, per dose does not mean this. It just means that each dose, so this will be 2.5 tabs. If it was asking tabs per day, then we would multiply it times 2, right? So onwards and upwards. Let's go to flow rates. So we have normal saline, also known as NS. We have 0.5 liters of that running over 3 hours. But we need to program the pump, right? And then if you haven't been in a hospital or seen one of these pumps, there's an Alaris pump, there's some other names. I like the Alaris ones. You'll get familiar with these as you get through the program. Milliliters per hour to program. It's supposed to be a question mark. Okay, so we need milliliters per hour, all right? So I know, just off the top of my head, that 0.5 liters equals 500 milliliters. Normally, when you're doing the test and showing your work, you have to show that conversion itself. Since I'm just showing you, I know what it is, and you do too, because we're all smart and we're all going to be nurses. So make it simple and sweet. So 500 milliliters over 3 hours, right? But we need to convert we don't need to convert. I can just run that. So in that case, I just divide 500 divided by 3. 500 divided by 3 equals 166.67, but then we get around to the tenths, so that is 166.7 milliliters per hour. And so this is the rate that we would type into the pump before getting the infusion going. Verifying that is correct. And that is correct. So we're good. That one was pretty simple. Let me do another one. So we have 2 grams of ampicillin, which is an antibiotic, to be given IV piggyback, diluted in 50 milliliters of D5W to infuse over 40 minutes. Okay. Milliliters per hour would be what? Okay, so let me think about this. So we don't even need to care about the grams, right? We have milliliters and we have time. This is all we care about. So if we have 50 mLs over 40 minutes, then we need to convert minutes to hour to get the milliliters per hour. So times 60 min over 1 hour, we can cancel out minutes, and then we would get milliliters per hour. So let's run this real quick. So we have 50 divided by 40, and then we're gonna times that by 60, and then we get 75 milliliter per hour. So that is what we would type in to the Alaris, and that is correct when I check my work. So now we'll do flow rates. Now let me just preface it by saying some of this material you won't see in your first semester. You'll see it second semester. But this is all stuff that you'll encounter. So let's fold this. All right, so we have 1 liter of normal saline IV to be given over 3 hours, just like the question that we had earlier. However, the drop factor, which is something you will learn eventually, is 10 GT per milliliters. That's 10 drops per milliliter. So that would be like, you have your little thingamajig that's at the bottom of your IV bag, your saline bag. So you have a little tubing going down from your bag up here, and then you have this little like plastic cylinder. And so the drop factor is how many drops per minute or per milliliter come through. Probably a terrible explanation, but for the sake of med math questions, that's really all you need to know. So 10 GTT per milliliter. So drops per minute is what we need to know. Okay, so think GTT and drops are the same. That's something you need to know. Okay, so I know 1 liter is 1,000 milliliters over 3 hours. So we're gonna need to turn that into minutes. So 1 hour over 60 min. And then we're also gonna need to throw in 10 GTT per milliliter. But we need drops on top. So 10 GTT per 1 milliliter. But that actually makes us able to cross out milliliters, cross out hours, and then we're left with GTT and minutes, which is exactly what we want, because GTT means drops. So let me do a quick calculation on this. We have 1,000 divided by 3, and then divided by 60, and then times 10. That gives us with 55.56. So we round that to the nearest tenth. That is 55.6 GTT per minute. Or, you know what? Actually, I've messed this up before. We don't round, because oftentimes, let me just check. Yeah, it doesn't even tell us to round. But we know that drops, just off the top of your head, you know that a drop can't be part, like 0.6. You can't have 0.6 of a drop. Like if you see a leaky faucet, you're not gonna tell if a drop is 0.6 of a normal drop. It's just a drop or not. So 55.56 is actually 56 GTT per minute. Let me check if this is correct. And it is. So we're good. So now you're catching the drift. We can go through a couple more questions, and then you will basically be ready to take your med math exams. Okay, so let's do this question. This question is 38. So we have insulin, 50 units of insulin in 100 milliliters of normal saline. and it is running at 14 milliliters per hour. Dosage needs to be given in units per hour. Okay. Now I'm reading up here like a full sentence and a half, but honestly, it breaks down to the information right here. You can throw out the medication, you can throw out the fluid names, and a lot of the other fluff. This is all you care about. So we need units over hour. So we can run this. We see that 50 units is in 100 mLs. We're going to put 14 mLs up top so that those can cancel, and then hour. And then boom, it's actually as simple as that. So we end up with units per hour, because that's all that's left with the units an hour right there. And then we can run the math real quick. 50 times 14 divided by 100. And that equals 7. Let me verify that that's correct. And it is correct. And so when you're actually writing this out or calculating this out on your calculator, you can do 50 divided by 100 times 14, or you can do 50 times 14 divided by 100. Since this is a relatively small question, it's very easy to do it that way. But for some questions, you'll have like 5 or 6 steps plus, and it'll be like there's stuff up top and bottom on each one of these. So in those cases, it's better to do something like 50 divided by 100 times 14 divided by XYZ times, whatever on top divided by that, and then so on and so forth. Because that'll make it flow better when you have these longer questions. But we actually haven't had a whole lot yet. So let's go over one that actually talks about safety. So here we have ampicillin, which is an antibiotic. There's 3 grams ordered to be given every 6 hours. Now the recommended dose, the recommendations, is no more than 14 grams per day. So we need to calculate and decide if this is a safe order or not. So in order to do that, we have to actually see how this calculates in a day format. So I know just off the top of my head, because I've done some of these questions recently, that there are 24 divided by 6 equals 4. So 4 doses can be given. So 4 times 3 equals 12. 12 grams is less than 14 grams. So it is safe. That one's pretty simple. Some of these are more complicated, as you'll come to find out. But for the most part, that's it. And then this last one that we'll do, this will be based on time. So let's see, we have an order IV 500 milliliters infusing at 200 milliliters per hour. The infusion begun at 15:48. We use military time in nursing and healthcare. So now we need to figure out the time of completion. This will help us decide when we need to start getting the next bag ready to infuse. So let's see, we have 500 milliliters, 200 milliliters per hour. So I can figure out, let me pause and think about this for a second. So 500 milliliters, we have 200 milliliters per 1 hour. So 500 divided by 2 equals 2.5 hours. 500 milliliters divided by 200 milliliters, cancel out the milliliters, hour, 2.5 hours. So I know that 2.5 hours later, it will be done. But now I need to add 2.5 hours to 1535, which is really just 3:45. So I can do 17. 15 plus 2 equals 17. And then 45, I know that 0.5 hours equals 30 min. 45 plus 30 in time equals 1 hour 15 min. So 17 plus 1 hour and 15 min equals 18:15 equals 6:15 p.m. Right? And so you can figure that out just like that. And let's see if I was right. I was. So as you can see, these are actually pretty straightforward. Some of these can be more difficult than others, but getting down the basics is going to be vitally important for you as you progress through med-math. But honestly, just doing practice questions is the best way to learn this and actually get it through your head. My school provides a massive sheet of like 50 plus questions of practice questions before each med-math exam, so that by the time we do take the med-math exam, we're more than prepared, and we're honestly a little burnt out of doing med-math. So the actual exam itself is not a big deal at all. But take these lessons, learn the conversions, learn the basics, and you'll learn all this during your first semester. So no need to do it before you get into nursing school unless you really, really, really struggle with math. But yeah, you'll be fine. You'll do great. And best wishes getting into nursing school or getting through the program if you're already there. And yeah, I'll see you around. And hopefully, if you're local to GCU in Phoenix, I'll see you in person. But best of luck and keep up the good work.